How many emails have I got? Oh, look at this. Tell Manu and James.
We're on.
We're on. Kia ora guys, I'm just getting started here. I'm just going to pop up the title screen so you can see what's going on. Sorry about the delay, but Harry from Radio New Zealand was here and he just wanted to have a chat with me first. So hopefully what you should be seeing now is a window that, let me see if I can see that window. You should be seeing a window that says 10 Mat CMT 2020, all year 10s welcome. If you guys can come on and just say g'day, that'll be great. Hey Finlay, how you going? Morning Alex. Hopefully a few more of you are awake out there. Just trying to see how many viewers we've got on. I think we might have a few random people joining us. So guys, just remember, if you wouldn't say it to me in class, don't say it in the chat. Right, brilliant. Okay. So we need to mute this, don't we? If you guys can mute that. Okay, hi James. Sign into chat. Why is it saying sign into chat? Cam, come and help. Right guys, thanks Finlay. Hey, I'm just going to wait for a few more people to join. Why is that saying sign into chat
You
there?
don't need to do that. Just
I don't need? So I can, but it's not letting me say something.
You should say something on the screen.
Oh, I say something on that screen. See why he's here? Right. Guys, I've got Cam here helping me. Morning, Ollie. Morning, William. Oh, look, we've got 6 have come in already. Right. Okay, kia ora, Liam. Oh, this is one of my old students. We're doing 5 times as well as the Swiss who are in full lockdown. Have a great class, everyone. That's from a former Year 13. Hey, George. Nice to see you. I hope self-isolation is going all right. He's just got back from Switzerland. So, morning, William. Morning, Ollie. Okay, hi, Alex. Just going to do a few more hellos. And Harry is here from Radio New Zealand, and he's on his way up to visit Manu and James at their houses in Karori. Mm-hmm. So, Manu and James, are you here yet? Manu and James are probably running around cleaning up their kitchens like I was. Yep, William, you can hear the cameras. That's right. Hi, Kate. Morning, Fraser. Okay, now look, while you're sitting here waiting, hey, Manu, good to see you. Hi, Penny. I hope things are good in Martinborough. Hi. Now, you can all quickly say hello to each other. That's all good. Hi, Viggy. I want you, while you're sitting here saying your hellos, if you can also go and open up your Education Perfect, you guys will see that I've set you 3 tasks, and I've scheduled those that they should have just come up. Liam, you only need to say hi once. Thanks. So if you go to EP, you'll see the tasks that I've set you for today. Liam, I'm going to boot you off if you don't stop saying hi, hi, hi. Right. First example. So I think we're going to get started in about 1 minute. Can someone just go and tell me if their Education Perfect tasks have shown up? Because what I'm going to do today is I'm going to talk you through what those EP tasks are, and I'm going to give you a little bit of teaching on them. All right? And Cam is going to take the role for me since he's come around to help me with the technology. So Cam is just going to make a wee list of everyone who's here, and I'm going to find my Algebra book so that I know what I'm doing. Right, so go look at your Education Perfect and then tell me when you've seen the tasks. Right, that's who's on. Good, right, I think we're nearly good to go. Yes, William, they're there. Mine have missed. Okay, so look, most of you are going to have 3 tasks. I'm going to hop over now into what we're doing today. We are starting Algebra, so I'm going to start with a Year 9 review. And then these tasks are due by tonight. So you know how I usually give you like a week to do them? We don't care when you do them today, but you need to do them today. So this is today's lesson, and there's quite a lot. So first we're going to do like terms, and then we're going to do multiplication and adding and subtracting with indices. So basically we're going to do exactly what we'd be doing in class. We're going to start with a tiny bit of vocab revision. So this live stream's probably going to go for about 20 minutes. Now, if it's way too slow for you, then you can hop off and do the Education Perfect. But I'd like you to hang in there for about 20 minutes before you do that, because from what I saw yesterday, most of you have forgotten most of what you learnt in Year 9, which is completely normal. Okay, so let's go. Flipping the laptop over. A little bit of vocab first. So here comes the maths. If you're still joining, you can hop in and say hello. I'm just going to start with an example, and I want to talk about 4 keywords that we need to have. So we've got 24x minus 6xy plus 5z minus 1. And the words are the ones at the top of the page, right? So we've got terms, variables, constants, and coefficients. So terms are like the building blocks of algebra. This is a term, this is a term, this is a term, and this is another term. And we have to be really careful with what we can add and what we can't. And that's the first topic today, that's like terms. Right? So those are the building blocks. Now the variables are the letters. Okay, so the variables in here are x, y, and z. The constant is just a fancy word for a thing that doesn't change. So the constant in here, and you can think about this in 2 ways. I would usually think about the constant with this sign in front of it. So the constant here is -1. And the last word that people forget is the word coefficient, which sounds fancy, but all it is it's the number that's sitting in next to the variable, right? So the coefficients here are, let's just write that down, we'll do pink pen. So the coefficients are 24, and then -6, and then 5. Coefficients are really important, and coefficients happen when I've done multiplication. So let's remember, what does that 24x mean? Well, 24x is 24 lots of x, 24 times x. But in algebra, we never ever write the multiplication sign, right? So we can delete that. So don't write the multiplication sign, just write the number before the variable. Also, don't write this. Oh, pen's gone. Whoop. X 24, right? That makes no sense at all. Guys, I'm just going to mute the video quickly and put some like terms examples up for you to try. Oh no, I'm not. I'm going to pop to that Education Perfect question. So that's one of the EP questions that you're going to get in your first Education Perfect task. I'm going to do that one with you to show you. So that's the next thing we're looking at, which is the idea of like terms. If you're a Year 9 and you're watching early, this is much faster than I'm going to go this afternoon, but you can have a look. So I'm just going to mute so that I can say goodbye to Harry, who's about to go and see James and Manu. James and Manu, get ready. Clean your kitchen or whatever you got to do. How do I mute for a second? This button here? Okay guys, I'm back. Harry's not here anymore. Who's Hash Brown? I can't access EP. Okay, Tyson, I will sort your EP out at the end of this lesson. So can you send me an email to remind me, because my brain is like a sieve at the moment, for obvious reasons. So anyone else who can't access the EP, let me know. And kia ora hamiora, thanks for getting here. I'm going to go back into the lesson now. Okay, so...
A lot of people have left.
A lot of people have left, have they?
Yeah, this is what you had before.
And how many have I got now?
Not the same amount.
Okay, they need to get back on. Who's gone?
Quite a few.
Okay. Guys, if you've got friends who've left, we're not finished. Okay? So I'm just going to go over to Google Classroom and say come back.
I think you'll be fine though.
Okay. Right. Okay, so we'll just keep on going because this will go up anyway. So I've still got most of you here, I think.
There's the chat.
Right.
You can continue.
Okay. So like terms go like this. We have to have exactly the same letters and the same numbers. So here are just 3 really easy examples from Year 9 to try that we looked at a little bit yesterday. In this first one, we've got x plus x plus x. So we can put those together because these are exactly the same variable. So that gives me 3x. In the next one, we've got 4x, 6y, and 5x. So these two are my like terms. They combine to give me 9x plus 6y. I can't add those together though, right? It's like adding onion dip and coffee. They just don't go together, right? They're different. They're not like terms. Okay. Next, we want to look at a slightly harder example, and this is one that students often confuse because it looks like in here we've got stuff with A, stuff with A, stuff with A, and then a constant. So the mistake that people make is to think that these can all be added up together and I'll get 2 plus 8 plus 5, 15 of them. But that's not right because A and A squared are very different things. A squared is A times A, and A is just A. So the like terms in here are the 2A squared and the 5A squared. They can go together. That gives me 7A squared. But the 8A has to be kept separate. It's plus 8A plus 7. And we can't simplify that any further. Okay? So that's how like terms work. The letters must match exactly. So that's your first education perfect task. I just want to show you 2 more examples in there. If you think about this one, which has got multiplied together variables, this is C times P times Y. But we know from Year 2 or 3 that 2 3s is the same as 3 2s. So the order in which we multiply doesn't make any difference. So C times P times Y is the same as Y times C times P. So when you're looking for like terms and you've got several variables in there at once, you just have to spot when you've got some that are in a different order. So the correct answer here, well, that one's wrong because it's 3 lots of PY, so that's not a like term. This one here, C times P, doesn't have a Y. That's not a like term. This one is a like term. It's 3 lots of CPY. This is CPC. The letters do not match exactly, so that's wrong. This is negative 3 YCP. So YCP is equal to CPY. They're just multiplied in a different order. And this is PCY, which is the same thing. So these are the 3 like terms in here. Again, that's a little bit faster than you would have done it last year because it's linking up ideas of multiplication. Right, so the Education Perfect task does quite a bit of this. You should be able to now go very quickly through that task. I think it says 22 minutes. There's no way it's going to take you 22 minutes. And don't watch all the yellow explanation stuff if you don't need to. So in here, the like terms are this and this. This is different. So this one will be 13 BTW plus BT. Right, we've done those. Next thing I want to look at is multiplication and BEDMAS. But first, I'm going to pause and I want you to tell me if you've got any questions on, I guess, on those 3 examples that I've done there. So can you come onto the chat now, please, and tell me you're understanding it or you're not getting it yet. If you're not getting it yet, you can try asking me a question. So guys, don't go away. I'm just going to mute and give you time to fill that chat in. And I'll answer some of your questions in the chat. Okay, I got a really good question just come in from Viggy. Better go back to the thing. Sorry guys, here we are. So Viggy just asked a great question, and it was, do you have to put it in alphabetical order? And William wants me to do one more example, so I'm going to do that now. Hopefully I'll answer both your questions at once. Right, so Viggy's question is, do we have to put it into alphabetical order? And the answer is no, you don't, but it's quite a nice habit to get into. So suppose that I've got, let's do one with this first. So we'll do one without the alphabetical order. So this is for William, this is an example for you, and I'm putting some negatives in here as well. So let's first look at the like terms in there. So everyone have a crack at that one in your book. We want to simplify that expression. So here are my like terms. This is 3x squared and this is plus 4x squared. So they're like terms, right? The 3x is a like term with the takeaway 7x. Now guys, notice what I'm doing here. I'm putting that takeaway sign in with the 7x. And then the 3 is a different kind of like term altogether. So looking at that, that gives me 7x squared from these two, 3x squared and 4x squared. Then I've got plus 3 minus 7. So one place people go wrong is if their number line skills or their negative number skills are pretty weak from year 9. If you're still coming up to speed on integers, it's totally fine to draw a number line like this. So we've got 3x here, and I want to go back 7. So we hop back 3 to 0, and then we're going back 4 more. We get to negative 4x. So this is here, minus 4x, and then my constant just sits there. Right, so William, can you just tell me if you're getting it now? And if you're not, I'll talk to you over email, because if you're asking, probably there's a few others asking. And Viggy, I'm going to do an alphabetical order one for you now. So suppose I've got 4abc plus 5ab plus 7cba plus 2bac. So my like terms in here, I'm slowing down so that you guys can think about it. This is ABC, this is CBA, which is just in a different order, and this is BAC. Just keep the sign with it. So they're all like terms, and Vicky, I don't have to put them in order, but it's easy to say ABC instead of BAC or CBA. So here I will. I'm going to go 4 plus 7 is 11 plus 2 is 13. So 13ABC plus 5AB. All right? And that's as far as that goes. Okay, now I want to go on and look at the next couple of things. So just going back up here, where are my 3 things today? So we've done like terms. Now we're going to have a quick look at multiplication and indices, and then how we add and subtract them. And I might actually hop over into the Education Perfect screen to show you what's going on there. So again, can you just hop on and say, yep, still getting it? Okay, so what we've got here is one of the Education Perfect examples that you're going to do. And you have to remember your BEDMAS rules whenever you're doing algebra. So BEDMAS tells me that the first thing I do is brackets and exponents. Right, that's the B part. Well, that's the B and the E part actually. Let me draw this how I like it. So I think of it as kind of a pyramid like this, because division and multiplication, you've got to do them together. It's not that division is higher up the food chain than multiplication. So it kind of goes like this, B, E, and then D and M as they turn up, and then addition and subtraction as they turn up. So in an expression like this one, we have to do the multiplication first. Again, I'm doing this at a faster pace than I would with Year 9. Right, good commenting, guys. I seem to have lost a few people. If you haven't said anything in the chat, oh, hi Dad. Yep, good to see that you can do Year 10 algebra 60 years on. That's great. Right, now 3 times 3j is what I'm going to do first. So that's going to give me 9 lots of j. Okay, when I'm multiplying, I multiply the numbers together first. And here, this is going to give me plus 8f. And that's as far as that can go. Now I just want to go over slowly why 3 times 3j gives me 9j. Let's think about what 3j is. It's 3 lots of j plus j plus j. So 3 lots of j plus j plus j is this. 1 lot of j plus j plus j. I'm now regretting the decision to choose 9, but there you go. J plus j, another lot of j plus j plus j, and another lot. But this is a big pain in the neck to write out, so we don't want to do that. So we very quickly get to the point where if we see 4 times 2a, we know that we just multiply the coefficients together. And you have to remember how your negative numbers go. Hang on, Alex, that's a great question. If you've got negative 4 times 2a, you multiply your numbers together. So you've got negative 8a. Right, Alex, great question. Alex said, hang on, are they not, how come we can do that? Because they're not like terms. Right, let's go back to this example. When I'm multiplying, I'm going to multiply my numbers. I'm not adding these two things. I'm first doing the multiplication, and then I'm asking whether I can add. So when I'm multiplying, I'm not thinking about like terms. I'm thinking about what multiplication means. So that's why this one here is 9j. And this one here is 8f. And now I ask the question about the plus sign, and I say, are they like terms? Right? So we're timesing. When we were back here doing like terms, we weren't multiplying. We were just adding. So that's why we're looking at like terms. Right? When we looked at these 3 examples here, we were adding. These questions are different because I'm multiplying. So I'm just going to find a couple of, can you guys just come on and say if you're getting what I'm talking about or not? Because I can do a wee bit more on this. What I'm going to do is give you 4 examples going from kind of starting year 9 up to end of year 9. So let's try b times a times 4, 5 times, or negative 5, times x times x times x, 3 times x times y, and now 4a times 5a. So have a crack at all of those. So Viggy needing a bit of help. Yep, that's great. Yep, great comments, guys. So just reply, I'm going to reply to some of those in the chat while you're doing some of these questions. So Viggy, here comes a reply to you. Right, okay, so let's go through these examples. Notice that there is no addition in here at all, so there's nothing on this slide to do with like terms. Okay, so number 1, b times a times 4. Why don't you put into the chat what you got for that one? Just type in your answers to what you got on that first one. Okay, so type in, guys. Type in number 1, 2, 3 or 4, you choose. Hi Jules, nice to see year 9 on here. Right, that's it, William. That's right, 4BA. That's right. So 4BA, I'm timesing together, so it's kind of like making fruit salad. Lovely, guys, well done. Okay, so 4BA, that gets a big tick. Or Viggy, if you want to do alphabetical order, you can, and it's 4AB. Awesome. right? That's really good. Okay, now the next one, I've put a step up in there. Put in your answer for this one, and on your keyboard, if you want to, just use a little hat key for the power button. That's a clue, you need the power button, guys. If you can't do that, don't worry, it's going to be a bit hard in the chat. But just put in your answer to this. I want to see how many of you remember how our index laws work from last year. Yep, Rex, you've got it. That's right, for number 3. Good. Cool. Okay, so for this one here, for number 2, first thing I'm doing is I'm looking at my coefficients. I'm looking at that -5. There are no other numbers. So my answer is going to be this. It's going to be equals -5, but now I've got my first example of an index. I've got x times x times x. So that's x, not 3x, but x to the power of 3. Okay, yep, lovely, Fraser, that's great. Really good. The next one is going to be 3x y squared. So notice that we're dropping the multiplication sign and we're putting any repeats into power formation. Nice work, guys. Yep, Tyson, it's fine that you can't find the arrow thing. I think we'll all get a little bit used to this over the next wee while, maybe. So that's all good. And then the last one, I've got 2 coefficients. I've got 4a and times 5a. So first I multiply together the 4 and the 5, and I've got 20. And then I've got a times a. So a times a gives me a squared. All right, guys, you are doing this so well. I'm really pleased with how we're going. Can you just quickly chuck me some feedback? Is this working? Okay, so quick comments, short speeches, be polite. Jules, great to see you doing year 10 maths instead of year 9 maths today. It's all good. Dad, are you still out there? And Manu and James, you have to tell me when Harry turns up to your place. 20. Yep, that's right, 20a squared. Great. Oh, Theo, what's... Oh, yeah, 20a squared. Okay? Because I've got a times a. Yes. Yes, what, Rex? Yeah. Oh, cool. Okay, good. Right. I don't want to get too long because I actually want you to go and do... hey, Bobby. Well, yeah, Bobby, I'm hoping that you can do this algebra, or we've got bigger things to sort out. Okay, next one. What's the next thing I'm going to do? Let's just go back here. So the last one is adding and subtracting indices. So I'm just going to do a few examples of this to show you and then get off the thing. Manu and James, can you make sure that Harry knows you're at the same house? Because that'd be all good. Liam, thanks for the comment. Right, okay. Next thing I want to do is some slightly harder ones. So let's do now -4x squared times x. We're building up to our index laws. And I'm going to be nice. We're going to get rid of that negative number. I'm not going to teach you that first. So let's think about what this means. I'm just going to change that example. I'm going to make it 4x squared times x cubed. So we could write that out painfully the long way. It would be 4 times x, right? That's what x squared means, times x cubed. X times x times x. We know what to do with that. It's going to be 4 times this thing here, which is x to the power of 5. But we don't want to have the times sign because the convention in algebra is no time signs because they're confusing. So that's my answer there. It's 4x to the power of 5. Right, now let's do a next one. So let's do 2y squared times 3y to the power of 4. And I'm going to do this one the long way as well, and we're going to start to see some patterns. So here we've got 2 times y times y times 3 times y times y times y times y. And we've got 6, so I can reorder the timesing, right? Because multiplication is commutative. So I've got 2 times 3 times y times y times y times y times y times y, which gives me 6 here times y to the power of 6. Now, hopefully you can see a shortcut. The shortcut is that I don't need to write all those painful y's out. I can just look at these powers and add them, and that's going to make life so much better. And you did that in year 9, but you've probably forgotten. So 2x to the power of 4 times 7x to the power of 10 will be 14x to the power of 14. 3x squared times negative 4x to the power of 7 will be negative 12, right? Multiplying these together, x to the power of 9. Yep, that's right. 6y to the power of 6. Good stuff. Okay. I think I'm going to stop the live stream here, and don't hang up yet, guys. I'll just do a couple more examples for you to try. Try that one. And then try this one. Try that one. And then one last one. I'm just going to take the brackets off. So just do those 3, and we're going to wrap it up there, and you can go and do some EP. So just if a few of you can just chuck your answers into the chat, that's working. I think that's working reasonably well. Algebra is much easier than some things. Will Robinson, you good? Liam, I'll worry about the attendance. If you could just worry about doing the maths. Thanks. Yep, Rex, you've got it. Rex, you are good to go. So Rex, you can go hang up now and do the EP. Alex, we've got a wee problem, just a little one. This is x squared, and this is x to the power of 4. So we've got to add those powers. So have another think. Okay. So yep, Rex, you're good to go. So catch you later. Guys, if you do get stuck with anything today, I will be checking my email. I'm doing some more live streaming. Yep. Where's yours, Alex? Didn't see it. No, Alex, yours is not right. Okay. It's much harder. Yeah, it is a bit of a step up, Finlay. Okay, I can do some slightly easier work if you need me to. So here, this is going to be h to the power of 3, because this is h to the power of 1, right? If you really need a slower revision, guys, you're welcome to come watch my Year 9 one, because we're actually on nearly the same topic. So I'm doing some of this stuff more slowly with my first group at 12:30. So you can join in, but I'll mostly be talking to the Year 9 guys. So here, this is b to the power of 11. Well, let's just make that a bit better. b to the power of 11, m to the power of 11. Good. Right, James, you're definitely good to go. Have a good talk to Harry. He's really nice. He'll ask you a few questions. And then that last one is 20x to the power of 7. Oh, I've just realised maybe Harry's recording. Oh dear. Okay, Viggy, you've made a wee mistake. It's h cubed. Okay, James, you're good. You can go hang up. Theo, you've made a little mistake as well. Just be careful. We're adding the powers. I can see what you guys are doing. It's because I didn't go over it. Bad maths teacher. Right. The h times the h squared bit, right? It's not just h squared, because it's been times by h. But h is h to the power of invisible 1. So put that back in. So that's h times h times h. So that's h cubed. So Theo, be careful of that. Who else has done that? Kate, you've got it. You're good. Well done. Viggy, watch out for this thing here. Tyson, 12:30 for the Year 9 live stream. Do exactly the same thing. Ollie, where are you? Ollie, you're good to go. Yep. Theo, you're good. Jules, you're good. I'd like you to join in on the live stream for Year 9, but we'll get you off and doing EP pretty quickly. And James, that's good. I really, really hope everything's good at your place. Say hi to Mum and Dad from me. Right. Okay. I think that's long enough. And please keep in touch during the day. Thanks so much, guys, for being my first guinea pigs. I'm pretty happy with how this has gone, and we'll have a talk about it in class when I see you next week. All right, so I'm going to go hang up now and get ready for the next one.